You've seen it everywhere. From ChatGPT to these mind-bending AI image generators, there's one core technology that's behind pretty much the entire AI revolution we're living through right now. It's called the Transformer. But what is it really? And what was the single, brilliant idea that unlocked all of this incredible power? Well, let's break it down.
To get to the bottom of it, let's start with what seems like a simple question, but it actually reveals one of the hardest problems in all of AI. For you and me, understanding context is second nature, but for a machine, it's a massive challenge. Just take a look at this sentence. So what does it refer to here? The sandwich or the restaurant? You know instantly it's the restaurant. But imagine you're a computer processing these words one by one. The word eat is right next to sandwich, but the real meaning, the real context, points all the way back to the word restaurant. Cracking this exact problem is the key to everything. Okay, so to really appreciate this breakthrough, we first have to understand why language is just so uniquely difficult for an AI. You see, before transformers came along, the models that were amazing at other things, they just could not get a handle on words.
Just think about the difference between an image and a sentence. Older models, called convolutional neural networks, or CNNs, absolutely mastered images. Why? Because they're great at finding local patterns. A pixel's meaning comes from the pixels right next to it. But language, it doesn't work like that. The meaning of a word on this page might depend on a concept that was introduced 10 pages ago. The connections are long distance, they're unpredictable, they're messy. And this way of processing things sequentially was just super inefficient. An old AI model might learn to recognize a tree in the top corner of a picture, but then it would have to relearn what a tree is from scratch if it saw one in the bottom corner. With language, this problem is 1,000 times worse. How is a model supposed to remember the word restaurant from the beginning of a sentence by the time it gets to the word it at the end? It just wasn't working. So how did researchers finally crack this problem? Well, the answer was a deceptively simple but totally revolutionary idea called attention. Instead of reading a sentence word by word, the attention mechanism allows the model to look at the entire thing all at once. And for every single word, it basically asks 3 questions. First, what am I looking for right now? That's the query. Second, what kind of information does every other word have to offer? That's the key. And finally, okay, based on that, what's the actual information I should pass along? And that's the value. By comparing its query to every other word's key, it can build this incredible web of connections, totally ignoring distance and focusing only on what's relevant. So let's bring this back to our sandwich problem. When the model gets to the word it, its query is basically asking, hey, what noun am I supposed to represent here? It then compares that query to the keys of all the other words in the sentence. It finds a really strong match between the it query and the restaurant key, and boom, it gives that connection a super high score. It learns to pay attention to the right word, no matter how far away it is. The whole process is actually incredibly elegant. The model looks at all the words at the same time. Then, for each word, it does a bit of math, a dot product, to compare its query with every other word's key. This gives it an attention score. A high score means a strong connection. And those scores are then used to create a weighted mix of all the other words' values. So the final meaning of each word is directly shaped by the other words it's paying attention to, building that rich contextual map.
This one idea, this ability to pay attention, completely changed the game. It wasn't just a small improvement, it was like unlocking a whole new level for AI, giving it a whole suite of new abilities.
Here's a perfect example from GPT-3, which, by the way, stands for Generative Pre-trained Transformer. You give it, I eated the purple berries. By analyzing the whole sentence, its attention mechanism instantly links the subject I with the verb eated. It sees that connection, and based on the mountains of correct English it was trained on, it knows that's a grammatical mismatch, so it makes the correction. This isn't just spell check, you know? This is real grammatical understanding. And here's the really wild part. Because this attention mechanism is so good at understanding relationships in general, you don't have to retrain these huge models for every single new task. You can just show them a few examples, a few shots, and they can adapt what they already know about context to solve a totally new problem. That amazing flexibility is why we call them few-shot learners. But the story doesn't stop with language, not even close. This attention mechanism was so fundamentally powerful that researchers started asking a really interesting question. What if we tried using this idea on pictures? And the results? Well, they were absolutely astonishing. Researchers started treating images like sentences. They would literally chop up a picture into a grid of little patches and feed them into a transformer as if each patch was a word. The model would then use attention to figure out the relationships between all the different parts of the image. And get this new approach, which was born from trying to solve a language problem, has now actually surpassed the performance of the specialized image models.
Of course, to pull something like this off, you need some serious firepower. An early version of this, called ImageGPT, used 6.8 billion parameters. You can think of parameters as all the little knobs and dials inside the model that get tuned as it learns. Having billions of them gives it an incredibly deep and nuanced understanding of patterns, whether those patterns are in words or in pixels. And the impact has been, well, everywhere. It's powering everything from object detection in self-driving cars to the AI image generators that are all over social media. It's the same core idea, calculating the relationships between different parts of the data to pay attention to what matters most. It turns out that idea is just as revolutionary for pixels as it was for words. So here we are, we're left with this single, incredibly powerful architecture that can find the deep, hidden structure in both language and images. It's a general-purpose tool for learning context. And now that it's basically mastered those two massive domains, the real question is, what complex system will it learn to pay attention to next?